My name is Brad Crookston. I'm a graduate student at Utah State University. Matt Yost is my advisor, and he asked me today to talk about some of the basics on soil health testing. So some of those other questions that were asked, hopefully we can address just some of the basics on that. I could talk all afternoon about the details of soil health testing, but today I just really wanted to answer three basic questions of, well, first, how would you describe a healthy soil, and what kind of goals would you need to have to achieve what you want in a healthy soil? And second, what kind of measurements do you need to take in order to link those goals with the kind of constraints or problems that you may be seeing that's preventing you from progressing in your soil's health? And then three, how do you track your soil's health, you know, over years and over decades? So just to start out with, just conceptually looking at soil health, high quality versus low quality soils, there's really these three domains in soil: the biological properties, the physical, and the chemical properties that all work together to contribute to a healthy soil. So you're going to have those beneficial organisms and low pest pressure. You'll have low compaction, good water storage and water supply, and a balanced pH, low toxicity, and optimal nutrients to keep your plants healthy. So all of these things work together. And if one of those is out of balance, then it's going to bring your soil quality down. And in contrast with looking at how do we even get to low quality soils, there's this spiral of soil degradation that's been identified in soil research, and it really kind of begins with really highly intensive tillage and not providing enough residues back into the soil to improve organic matter. And without those residues, you're going to increase risk of wind and water soil erosion. And so it continues down the spiral of decreasing soil organic matter. You lose your aggregates and decreasing your soil water storage. And eventually all of these just really contribute to decreasing yields that you'd see over time. And so the idea with looking at soil health is really, how do we prevent these steps from continuing down and degrading our bottom line? And so researchers have also identified this continuum of healthy soils. And on the right, with high health, we have perennial cropping systems, which are really dominant here in the Intermountain West with hay and forage and pasture. And also CRP land, you'll be seeing better soil health on that end. In contrast with your annual cropping systems, if you have really intensive tillage, monocultures, low diversity, it's going to take a really big toll on your soil's health. And so over time, you just really get stuck into that downward spiral of soil degradation. So looking at those concepts, we ask the question of, well, how do we improve our soil? So your goals of improving the quality of your soil really needs to be based on your soil type and also your management, just like what we saw on that continuum. So for example, if you want to start improving your soil's organic matter, it's going to depend on the inherent soil properties, such as soil texture. Starting with 2% organic matter in a silty clay loam is going to be a lot different from trying to get to 2% organic matter in a loamy sand. You just may not get there. And this is data that I'm presenting from the Soil Health Partnership in the Midwest. But you can really get the idea that soil health is kind of this relative concept based on your environment and your soil type and even the management where you're starting from. So really we get this question of what is soil health? In the simplest terms, it's the capacity of a soil to function in supporting crop growth without degrading your soil. So in identifying our soil's health, and starting from where we are in our environment, we want to connect the biological, chemical, and physical functions of the soil that support a productive crop we want to connect those things with the kind of constraints that we may be seeing that are preventing our crop from being what we want it to be, or from preventing our soil from improving its health. So for example, with the chemical properties, you're looking at nutrient supply for its soil function, and you may be seeing poor nutrient balance. And so connecting your measurements with those functions and constraints, you're going to want to take measurements of organic matter, pH, and your overall nutrient elements. With your physical constraints, you may be seeing soil compaction. So you have lower water supply or lower support for roots in deep rooting plants. So you want to take measurements of bulk density or aggregate stability or even available water capacity. So these are just some ideas of places you can start so that you can start to get a good picture in describing the status of your soil. Now, interpreting those measurements, for example, looking at soil biological activity or organic matter, your soil's health is going to improve as that indicator measurement increases here. So we have this more is better curve, and as that value increases, you're going to have better soil health. Versus with pH or phosphorus, you're looking at this midpoint right here in this middle range, and you're going to have better soil health. Versus with bulk density, if you have lower bulk density, your soil's health is going to be better overall because your soils aren't going to be restricted by any compaction layers. So now to help you progress on this path towards improving your soil's health, researchers have developed these assessment frameworks. The first one was the Soil Management Assessment Framework, developed about 15 years ago, and that's mainly used just by researchers for soil health. But commercially available, we have the Comprehensive Assessment for Soil Health, which was developed by the Cornell University Soil Health Lab. There's also the Haney Soil Health Tool, which many of you know. The NRCS will cost share that for you. And then also many other universities, for example, Missouri Soil Health Test Lab, you can send samples into them and they'll assess your soil for you as well. So just some examples of some of those reports that you're going to be getting back. For example, Ward Laboratories, they'll do the Haney Soil Health Test for you, and you'll get back these various numbers. And these are really focused on your soil's biology. And overall, they're going to give you this soil health calculation, this score. Sorry about that. The score for the Haney Soil Health Tool, it's on a 0 to 50 scale. So a score of about 10, you may be looking at, medium to low quality soil. And this will give you an idea of some directions that you need to go in to improve your soil. As well, the Cornell Soil Health Assessment will give you a little bit more detailed information based on which indicators that you've selected to get tested. They'll give you a score of 0 to 100, and then they'll show you some of those constraints that may be limiting your various soil parameters that you're testing. So what's the cost of tracking and testing your soil health? For individual tests, you could start out with just organic matter, and that ranges anywhere from $10 to $25 depending on the lab that you're getting the test run at. All the way to this phospholipid fatty acid test. That's a soil biology test that's going to cost you a little bit more. And if you want to go ahead with a full suite of tests for the comprehensive assessment for soil health at Cornell, it's going to be around $60 for the full suite of that test. It'll range from $110 up to $150 per sample. So it really kind of depends on your goals and your management, what you're trying to achieve. You know, just the thing that I would recommend is just start small and start simple so you can track your progress over time. So how often should you sample? It really depends on the measurement that you're taking. So for a chemical test, it may range from every 1 to 3 years. Biological and physical, so continues on and so forth. So if you just wanted to measure all of those properties all at once, I would say just go for middle of the road, maybe every 3 years, and then it's easy for you to be regular and consistent with your measurements. And that's really the goal, is to track your progress over time with these. So the soil sampling best practices, you really want to follow a consistent pattern. And that's going to be based on the kind of goals that you have for your management. So for example, in this top figure, if your soil is, if you know that it's pretty uniform, you get uniform yields throughout the field, except there's this one trouble spot, you can take a composite sample throughout the field. Versus you have two different management zones. You have no-till in this area versus regular conventional till. You want to avoid any problem spots again, but then send in two separate samples based on your management zones or your yield zones in your field. The typical materials for soil sampling is pretty much the same that you would have. You want to keep your records and have separate sample bags for each sample that you have. For soil health sampling, you may want to use a soil penetrometer reader to measure the soil compaction that you may have. But also really important for biological tests is to keep it on ice and have expedited shipping so you can preserve that soil biology. So just in summary, what kind of soil do you want? It really depends on your goals and your soil type and management. You have to work within those constraints of the inherent soil properties that you have. Now, which kind of measurements should you choose? That's going to depend on what type of hurdles that you're trying to overcome that's preventing you from having better soil health. You want to connect those hurdles to the soil functions and also the measurements, so you know what are the right analyses that you need to ask the lab to perform on your soil sample. So then tracking your soil health over time, these soil health assessments that have been developed by these labs throughout the country really offer an opportunity to simplify it for you. So if you want to do the full suite, it's just going to cost you a little bit more money. If you just want to start simple, which is what I'd recommend for anybody just trying to start out to measure their soil health, I would say organic matter is probably a really good place to start. So your soil sampling, again, will depend on the kind of property that you're trying to measure, but the key is just to be regular and consistent about your soil measurement and testing. So just a final thought, I like to visualize building soil health just like building a house. You're going to have a vision of the kind of home that you want to live in. So you have to have the right kind of goals and the right kind of measurements and the right practices and materials in order for you to achieve that vision for your home. And it's really no different for your soil and for caring for your soil resources on your farm. And with that, I want to thank you for your attention. And here are some resources that you can go and look up for additional information as well. So that's it for me. Thank you.